So I'll say, first of all, tēnā koutou, tēnā koutou, tēnā koutou katoa, or kamsahamnida, or thank you and greetings and thank you for being here to listen to me. So the first greeting was from my native tongue, New Zealand, where I live, way down the bottom of the southern hemisphere. And that's Maori greeting to say welcome and thank you for coming to join and listen to me. And then obviously I spend most of my time in South Korea, and so kamsahamnida is welcome and thank you for listening to me.
Значи благодаря на всички, че са дошли, идва от Нова Зеландия и поздравления за това, че всички ще присъстват днес.
So I was born in New Zealand a long time ago. I'm a little bit older than what I perhaps my youthful appearance. I was diagnosed with type 1 in 1986 by my father. So I come from a medical family and I have a very, very unique diabetes. So perhaps nobody else in the world, I believe, has the same upcoming as what I have experienced. So my father is a pathologist, and so he diagnosed my diabetes very, very early. So when I was first diagnosed with type 1, the endocrinologist told me to go away and come back in 6 months' time when I need insulin. But my father, as a pathologist, said no and started insulin intervention very, very early. So I essentially, from the age of 14 years of age in 1986, had what I consider a honeymoon phase of all the way through my teenage years. So I was on very, very low dose insulin all the way through till about 22 years of age. Okay?
Това, което каза, че той идва от Нова Зеландия. Баща му, четвърто поколение е роден в Нова Зеландия. Баща му, неговият диабет е уникален, защото още от малък 14 годишен има диабет. Установяват му диабета на тази възраст. Искали са отначало да го минат на по-висока доза, но баща му е спрял това, което иска ендокринолога и са го минали на много ниска доза инсулин.
So also in addition to my father, who's a pathologist, my grandmother graduated from medical school in New Zealand as the first female surgeon in 1939. So she's passed away many years ago now, but I had my grandmother as a surgeon at home, I had my father a pathologist, and my mother was a pharmacist or a chemist. So I had a clinical team with me every single day. Okay?
Общо взето семейството му са доктори и се образува като един тим, лекарски тим в тях.
When I was very young and early diagnosed with small dose insulin, my father very quickly realised that when we had a cloudy monotard insulin and you mix it with an actrapid, they both became a fast and a slow became a medium. So right from about 1987, I was taking 7 or 8 injections per day because my father said that they were better by separating. So this is many years before ADA recognised that MDI was good.
Инсулина, който се е слагал, смесвали са бърз с бавен инсулин, правил се по 7-8 дози инсулин на ден. И какво ще каза?
След това баща му открил, че е по-добре като са...
Да, като се смесват дозите, отколкото да правим 7-8 пъти да се бавим.
Okay. So obviously I started on a pump very, very early because many injections as a young person was no good. And pumps back then were very big and they were very basic and they weren't very smart. But I was on a pump very early and I've never stopped using a pump.
Значи много отрано е почнал с помпената терапия и никога не е спирал както е почнал.
And I was involved in a very early Dexcom 3, they called it Dex 3 study at Stanford University back in about 2003. So I've continued to use a Dexcom CGM ever since 2003.
От 2003 ползвал системата Dex 3. Съвсем още от първите пионери, които са почнали с тази система.
So I live in the very beautiful New Zealand with my family. So I have a wife and a son, and obviously we have a very beautiful country. And I get to see my family about half my time because I travel a lot.
Това е семейство, но да.
And obviously, once again, I'm very lucky and very blessed to be living in New Zealand.
You're on a boat?
Sorry. And look, I suppose that a couple of other people here in the room are also pioneers of APS, and I was very fortunate or very lucky to start APS as one of the There was a group of us that started within a week.
2016 September.
September 2016 was when I started on APS.
Радва се, че заедно през 2016 една част от хората, които сме стартирали с APS, общо взето 4 човека 2016, по едно и също време сме почнали с APS.
So when I started, I was introduced to APS by Peter Vorcha from Czech Republic, who knew Miloš very, very well. And Peter had showed me, actually of all places, in 2014 when I was at Sunny Beach in Bulgaria, he showed me an old Windows-based phone communicating via text message to deliver a bolus on a Dana R pump. So they had started with this technology in the Czech Republic long before Miloš even got started with the system. And so the concept of it had started many years earlier.
Това, което системата е тръгнала много по-рано. Петя, когато е дошъл, нали Петя, казаха ли си? Да. Петя е дошъл в Слънчев бряг и тогава той е видял как системата може да комуникира с текст меседж, да се праща болус към помпата. И по-късно с Милош съответно се разговаря на тази тема.
I don't need to explain because everybody here I think understands the APS system, but what I will talk about when I talk about APS is my introduction to Miloš. So obviously he started the system for his daughter, and I was one of the, like I said, there was a group of us from here from Bulgaria that were very early in the beginning of September 2016. I had a very funny introduction to APS because I was in South Korea at the time and I just finished a congress in Europe, and Miloš had remote controlled into my computer and using TeamViewer had set most of it up for me remotely. And so I raced home on a plane and arrived home with my family, and I took my wife and my son out for dinner and we went to a lovely Indian restaurant. So I had a huge high carb Indian meal, but I had made a mistake because this was brand new to APS. So one of the things that I did was that I had my Dana R remote control and I bolused from the remote control because that's what I've been doing for years. It was just familiar. And I left my APS rig in the car and it was remotely talking to me because I was just outside, but it didn't know that I had IOB and I made a mistake. So anyway, at the end of the night I had a catastrophic hypo because the system was doubling and trying to work against itself. So I got on the phone the next morning to Miloš and said, Miloš, this has happened, how do we fix it? And so Miloš discussed with me that at the time he had hacked the Bluetooth code about 65% of the Dana R. And he said to me the only way we can make it better was that if I have the other 35%. And about a week later I went back to South Korea and I spoke with Professor Choi. And so Professor Choi and I gave and gifted Miloš the other 35% of Bluetooth code. And that was the interaction. It's where Soul Development Co. and Miloš and the Open APS community had started working. And so within a week or two we had an update to the system, and all of a sudden the APS system had feedback from the Dana pump and it was reading history. And it made the system safer. So if I'd made the same mistake again, it wouldn't have done the same. Okay?
Значи, когато е бил в Корея, с Милош са се комуникирали по телефона, след което се е прибрал и в ресторанта, учи се на индийски ресторант, пуснал си е болус, като Орига бил в колата, по някакъв начин е имал грешка, не е това, което е пуснал и...
So, in a very similar arrangement to what we have here, is that in December 2016, I invited Miloš to come to South Korea, and we introduced him to Sugar Tree of South Korea. And many of you may well know Myung Kim and Sugar Tree. They're part of the Night Scout Foundation of South Korea, and they wanted APS to be working on the Korean domestic pumps. And so we brought Miloš to South Korea to rewrite the code for a different type of pump because the domestic pumps were different. And during that meeting, Miloš and I wrote a wish list in the boardroom at South Korea, and we said what a pump should have for APS. And we started off by saying 500% temporary basals. We actually started with saying 1,000% for 24 hours. But Professor Choi said that that was unsafe and it was perhaps risky, and so we had some work and we came back to some compromises that would work for APS and work for the medical device industry. So we sort of collaborated and we worked together.
След като са говорили с Милош, са го привлекли да работи към за подобряване на тази система, да разработят заедно тази система, са питали какви трябва да бъдат от двете страни да направят компромиси, за да може да работят заедно.
Less than 9 months later, at Portugal EASD, we released with CE mark the Dana RS pump. So it was a very fast track in development from the open APS community to develop a pump that was best for APS.
Дълъг път е изминал, докато се разработи, докато стигне до Dana RS.
It's just a promotional video, I don't need that. So a lot of people here understand Saul and they know where they came from, but I don't know if many of you know Professor Choi and where he comes from. Professor Choi developed the very first insulin pump that was commercialised in 1980. So they have a very, very long history. This year is our 40th anniversary of building pumps. So that's 4 years before Medtronic made their first pump. In Europe and Australasia, we've been exporting pumps since about 2005, but we're still relatively unknown. In South Korea, we have 95% of the pump business, and we have about 50,000 patients using pumps in South Korea. In China, we share the market 50-50 with Medtronic, and we have half the Chinese market. Okay? So we're very, very big in Asia, but not so big in Europe, and it's only been in the last maybe 5 years that we've started to expand into Europe and Australasia.
В началото, 40 години откакто се занимава професор Чой с този бизнес с помпите, като пазара им основно е в Корея, над 50 хиляди души използват тази помпа, като след това отиват и в Китай и последствие в Европа, Щатите, Австралия.
Back in 2017, we started with the JDRF and the Open Protocol Initiative. And essentially where it comes from is that currently at the moment there is one commercial system available in the US, and it's just coming to Europe at the moment as a commercial closed-loop hybrid system. But all three components, the algorithm, the pump and the CGM, are manufactured by one company. And nowhere else will that ever happen again because there's no one company making CGM and pump and algorithm. So the JDRF and the FDA can see that they need to draw some guideline for the future. Because in the US market, everybody's worried about who to blame when something goes wrong. Who do we sue? That's typical of the US market. So the Open Protocol was initiated, and we've been part of the Open Protocol initiative in the USA and guiding FDA as to how we can make pumps regulated for the future. And this is kind of how they see things working in the future. And what they're working towards is iCGM, which is the G6 system, is the first iCGM. We have an iController and we have an iPump. And basically all of them are interoperable and they will communicate freely between each other, given the guidelines. And it's the only way forward for all pump manufacturers and for CGM because we're not making them from one company yet.
Значи това, което става в щатите за другата система, че помпата и устройство за мерене на кръвната захар и контролера се разработват от една компания и според щатските закони не може една компания, трябва някой да поеме отговорност, ако нещо се обърка в цялата система, не може една компания да излезе на пазара с 3 устройства за затворен кръг на системата.
So very similar to Tidepool with Loop and how they're trying to get a regulated system available. Saul Development Co now is working very, very hard with the FDA to try and get a pump of ours regulated into the US market as an ACE pump or an iPump. And we hope to do that at some stage this year. And after that it will come to Europe as well.
Значи първо в щатите ще бъде одобрено, след това в Европа. Става въпрос за затворената система за APS.
So I copied this from Dana Lewis's presentation at ATTD this year, but DIY. Why would I want to DIY a system when there's commercial systems available and also when I've always had such good control? I mean, I've always had experimental medications, I've had experimental insulins before they're approved for regular use. I've had a family that look after me every day for my whole life, and so it's a very unique situation and I've had great control, no complications, and 32 years of type 1 diabetes, so why would I want to build my own APS system? And the key thing that I try to say now is the reason is time. Is that diabetes consumes an enormous amount of my time. Every day calculating, thinking about what I need, what I don't, how much insulin I've got on board, what I haven't. And DIY has enabled me, or APS has enabled me to have free time. And I have 1 hour free time every day because of APS.
Това, което е презентацията, е купира на обдей на Луис. Основното, което е времето, което спестява, дали е с DI или OpenApps, времето, което се спестява за когато се използва тази система.
Yeah. So essentially it's very, very simple here. So basically, I don't do anything anymore. So I've been talking with some people today about how I'm able to do it, but I'm not bolusing, I'm not pre-announcing for meals, I'm not doing anything at all. I'm allowing the loop and the system to control everything for me. It's no longer a hybrid APS, it's a full closed loop.
В тази затворена система той не прави нищо друго, само обявява храната и системата работи сама.
So aside from the obvious benefits of increased life expectancy and low complication risk, I now live 1 hour extra every single day because of APS. So I have to give a very, very special thank you to my very special and dear friends Dana Lewis and Scott Lebrand, obviously Adrian and Milosh that many people for the Open APS community know. And then obviously also these people on here, the Diabetes Mind Congress, Tide Pool, JDRF and the FDA, because I think the FDA is open to the DIY community. They're listening to us and they're wanting to regulate and make these systems more available. I'll talk a little bit now about Seoul in the future and what we're doing. Obviously we're looking at the FDA, we're moving to a new factory next month. So we're moving into a new facility in South Korea. Our sales growth have been substantial thanks to the APS community. But we also have some new pumps coming for the FDA market. We also have
благодарение на работата им отварят нова фабрика в Сойл, като пазара същевременно нараства и подготвят нова помпа, която ще излезе на пазара.
A very interesting one here is Dana CGM. So we are developing a CGM system. I've been using it for about 3 months or 2 months at the beginning of this year.
Новата система е CGM, върху която работят. Ползвали се вече 2-3 месеца работят върху нея, са правили опити.
And more than likely that will be released at EASD in Barcelona this year. So
ще бъде пусната най-вероятно тази година в Барселона, ще има презентация, там ще бъде пусната система, ще бъде обявена официално.
Another one here is listening to the community about people wanting better and more infusion sets. So there's 2 things we're doing. One of them is we're working now with Uno Medical, and the Inset 2 infusion sets will come to Dana range later this year.
Ще има допълнително и сетове, понеже хората се интересуват също от сетовете. Ще има едно вид сетове, Dana Inset 2.
And we're also making some new 31 gauge, Dana Superfine, which is a very, very nice needle. I'm using them right now.
Да, самия сет с много тънка игла, 3.1G, което е инсулинова игла за сета.
And then obviously also Dana Loop. So we have the OREF1 algorithm in collaboration with Dana and Scott and Milosh.
Алгоритъмът, който е разработен от Дейна, Милош и Скот в
OREF1.
И ще ползва този алгоритъм, ще се ползва в тази система Dana Loop.
So we're locking down some restricted features. So you won't be able to set a target BG of 3.5 millimoles. It'll have to sit within a reasonable target range, and we will lock this type of CGM you're using, and then we will apply for CE mark for that later this year.
Ще бъде в някакви не много ниски граници до 3.5 заключена системата и ще я предложат за одобрение в FDA.
And I have to give a very special thanks to my very dear friend and my boss, Subong Choi, because look, Professor Choi and I have been working together or collaborating together now since 2009, so I've been involved with the Korean company now for 10 years. And look, Professor Choi really genuinely does want to bring joy to people with diabetes. And look, he's trying very hard and he's always working very hard towards this, but he's a genuine man of compassion and he loves helping people with diabetes.
Благодаря на професор Чой, който винаги е бил подкрепа на хората с диабет. От 2009 година Justin работи в тази компания.
And look, I'd dearly love to answer any questions that anybody might have. I'd love to help, advise or help any more.
Ако някой има въпроси, моля да ги зададе. Ще се радва да помогне.
Значи, моят въпрос е, предполагам, всички сте чували, че Медтрonic разработват сет, който ще бъде с две дупки, за да може, ако случайно едната дупка се запуши, което често се случва при малките деца, да може да остане втората свободна, оттам като оставя инсулина, съответно да не се вдига кръвната захар. So I suppose you know it's about the new sets you're launching. Medtronic are developing a infusion set with 2 holes on the cannula.
Yep.
Is it something like this that you're going to?
No, because that's patented. That's actually owned by BD. So Medtronic have been collaborating with BD. Okay, is one thing they've been doing. Interestingly enough, is that their set has actually been withdrawn from market. They did do a soft launch and then it was recalled. And it was recalled because they're having splits and they're having problems with lots of occlusions and breakage of the cannula. It's very, very complex to try and make a soft Teflon cannula with a hole in the side. So thank you.
Yeah.
However, interestingly enough is that I'm working on some similar technology. We're working in a different way to what Medtronic are doing. Like I said, I've had a very unique upbringing with diabetes. One of the very interesting things that I saw about 25 years ago, or 20 years ago in North America, there was a small company called 50/50 Pharmacy, and they manufactured an infusion set that was about yay big. And it had 50 1mm needles in a big patch. And and it had one tube going to it. And basically you went, it was on, it was only just under the skin, and it was very, very good. And it worked incredibly well. Except, because you had 50 needles, you only needed one of them to break free, it'd leak. So the set failed, it went through a small clinical trial and never came to eventuate to anything. So one of the things that we're looking at and we're working with Professor Choi is making a multi-needle infusion set, and they're very short needles, so maybe 2 or 3 millimeters long, and there'll be 2 or 3 infusions. Okay, so a multi-infusion set. And the reason being is that over the course of diabetes, I've been using a pump since 1991, but pen needles have gone from 14 millimeters to 12 millimeters to 10 millimeters to 8 millimeters down to now 6 or 4. And the reason being is that we get better insulin absorption closer to the skin. But with a pump, when you bolus into it, you get a big puddle and it leaks, tunnelling. So we're trying to get insulin close to the surface of the skin, but keeping it there safely. And the best way that I see doing that is through multi-infusion. And so we're working on some multi-infusion sets that may come to the market next year. Things take a long time for regulatory approval, but thank you. Yeah.
Това, което той обясни е, че този, за който ви казах, те го пуснаха, мисля, че миналата и по-едната година за тест на няколко месеца в Щатите, но имало доста проблеми и след това изтегнат пазара, защото е много трудно да направиш мека канюла с дупка по средата. Нали, то звучи страхотно. Затова те работят по подобен вариант, но искат да го направят с игла. Имало е един сет на преди време, който е бил толкова голям, както той показва, с 50 игли, който се е слагал на ръката. Но проблема при него е бил, че когато една от игличките се отлепи, е започвало да изтича инсулина и съответно не е бил ефективен и поручването е спряло. В Сойл работят по изработването на такъв сет с няколко игли, за да може да се доставя инсулин пълноценно и живот и здраве до година, може би, ще на линия.
Какво?
Дали ще има контейнери за резервуар?
The reservoir with quantity less than 3 milliliters.
No, we will always. We did start some work, some collaboration with Novo Nordisk about 18 months ago, because Novo are making a 2 ml pen-filled reservoir to go into pumps. But the problem is today in the community that we have new insulins, Fiasp, you have Apidra, you have many options, and people want some choice. And if we sided or collaborated with one company, then you have no choice. So to enable people to have choice, we will always retain a 3 ml refillable reservoir. And for me personally, I actually mix insulin. So I'm using Fiasp and Novo, and I'm mixing 50-50 because it's better for me. So we want people to have choice. So we won't side with one pharmaceutical.
Значи, за да имат хората възможност от различни фирми да се ползва инсулина, не е фиксиран и специално той се смесва двата вида инсулин, бърз и бавен, и ги смесва в един резервуар. Бърз, извинявам се, бърз. Да, Fiasp добро пит.
Ще има ли възможност само пенфил да се зарежда? Да няма резервуар, да се избегне резервуар?
Is it possible without reservoir, only penfield? If you get penfield,
No.
put it inside in the pump.
Desertronic many years ago had a pump, the H-Tron, that used a penfill reservoir, but the penfill reservoir has inaccurate walls in the reservoir. So the basal delivery was inaccurate. So it's not possible.
Не е възможно, преди време са ползвали такъв резервуар, но стените са, самия резервуар не е с еднакви размери и оттам се пораждат проблеми, с това са го спрели.
Защото има много често проблеми в резервуара, се газира инсулина, едни мехурчета се получава. Следователно въздушаване, което много инсулин изхъбяваме.
They speak about the problem when necessary to refill the reservoir, and there is a lot of bubbles, and was necessary to deaerate the reservoir.
Okay, bubbles are caused by user error. Okay, 100%.
Балончетата се появяват следствие на грешка на потребителя, на ползвателя.
I have
Грешка се едно.
Къде да търсим грешката, проблемът е...
How to find and how to solve the problem
Okay.
with bubbles.
If anybody wants to know about bubbles and reservoirs, I'm more than happy in a small, maybe satellite group, we'll talk about it later. I've got another presentation where I teach people to refill any pump with no bubbles. And there's lots of small tricks that we learn over 32 years of pumping.
След презентацията ще ви покаже трикове как да се пълнят резервуарите без балончета.
Yep. Okay? Thank you.
Hi.
Yep.
My question is whether you plan to use the new technologies in the software industry like machine learning and artificial intelligence in order to calculate all these numbers? My question.
Okay, good question. From the core business of what we're doing is that we're a pump and ultimately a pump and CGM company. And so our core business is selling infusion sets and pumps and selling CGM systems and sensors. So the algorithm we want to be leaving open to the open source community. We want to collaborate and work with open source, but open source is moving faster than what the medical device industry is, and we believe that the future is innovation through open source. So we will continue to make a digital syringe driver, a very simplistic pump that communicates remote control to the eye controller. The eye controller can come from you guys.
Do you plan to collaborate with other giants in the software industry for
No.
the software, or it will be open source?
No, the complication.
I'll translate in the
Yeah, sorry. The complication we have with that side of technology, and it is the future, is regulatory approval. It's unbelievably frustrating and incredibly difficult to get approval for some of the most simplistic things. And for instance, one of the ones I showed you there before was the Dana Inset 2. So the Inset 2 is an infusion set that's been manufactured by Unomedical 12 years. Okay, so they've got a long history. It's FDA approved, it's CE approved, manufactured in Mexico by a Danish-based company. We collaborated with Unomedical in February 2018 to make the Dana Inset 2. So all we have to do is change the direction and make a proprietary connection on the end of the tubing, and it's taken us 18 months to get approval from CE to sell it. And it's just crazy. It's unfair for the medical device industry that things take so long. And so working for artificial intelligence and things like that, the reality is you're probably talking maybe 10 years to get approval because of the safety and the clinical trials and the study and the money involved is astronomical.
Значи като цяло попитам дали може да се използват най-новите достижения в софтуерната индустрия като изкуствен интелект и машин learning, което да се приложи за изчисляването на всички тия сложни числа, за които се говори. И той отговаря, че е много трудно да се направи от една компания, има много апрували и това те искат да го оставят като сложна задача open source, което означава целият свят да контрибютва, който иска програмист, да се занимава с това нещо, понеже самото му стандартизиране е много сложно. Първо, че никой още не вярва на machine learning и на artificial intelligence, защото най-съгласете се, това е софтуер, който имитира прямо мисловна дейност, образно казано, и поради тази причина те се отказват да инвестират в това, оставят го като open source в най-така изказване. Thank you.
That's right. But one thing I will add to what you're saying about artificial intelligence. Professor Choi is a professor of endocrinology. He's been making pumps for a long period of time. His first son, so he's got 3 sons. His first son is a professor of endocrinology who studied endocrine at Boston University in the United States. Whilst in the United States, he met his future wife, a Korean girl who's also an endocrinologist. So in the family business of Soul Development Co, we have 3 endocrinologists within the company. Professor Choi's second son is working, he's just finished a postgraduate degree in Boston also, Washington University, in artificial intelligence. And at the current time, he's about to go and do his first job outside of the university for someone like Google in a big company for 3 years. And then Professor Choi wants to bring him back into Seoul to work on AI with the pumps. But reality, it's going to be a long way. It's dream in the future.
Професор има като част от семейството си 3 ендокринолози, нали, в семейството. Сина му е даже PhD той има PhD по Artificial Intelligence и всъщност той иска да го придържа първо да поработи за Google, след това да го вземе в компанията и да почне да контрибютва по софтуер, който да е базиран на изкуствен интелект и това е далече в бъдещето все още. Thank you.
You're welcome. Thank you.
Може ли да задам и аз въпрос, тъй като съм базарен на инсулиновите помпи, дали познават с техен конкурент в Швейцария, който разработва в момента помпа в клинични тестове и дали ако го познават, биха ли могли да споделят техните предимства на помпата, която разработва, спрямо тази, която се разработва?
За коя помпа става въпрос?
PharmaSense е фирмата, която разработва.
PharmaSense.
PharmaSense.
Do you know the company in Switzerland, PharmaSense?
No, what are they making? Okay.
Затворена система с датчики.
They have also, he explained that this company also working on closed system with sensor and pump.
Yep.
But you don't have any info about it.
No. In global studies around the world, some of the key ones that we know about are Roman Havorka at Cambridge University in the UK, who's been studying artificial APS systems for 5 years. He's published many papers. So Roman Havorka is using the Dana RS pump in his current system. He's got a clinical trial with 50 patients around the globe that are using an APS. And Roman Havorka intends to commercialise his system this year. So in Barcelona, he'll probably release it as a subscription, which will be a CE-approved artificial pancreas, available for purchase through Cambridge University. Okay. In addition to that, there's also a Danish study, and the Danish study is run by Zealand Pharmaceutical, and Zealand Pharmaceutical are working towards a dual hormone APS, and they're also using the Dana APS system, or Dana RS pump for their dual hormone. The Linker study in the Czech Republic is also using Dana RS pumps with their closed loop study for Open APS CE mark. So nearly everybody around the world is choosing Dana RS for Bluetooth Low Energy. So the BLE the communication protocol we have is number 1. And everybody wants to use our pump in the study, and we're collaborating with many companies. The other one we're also working with is Diabetes Loop. So Diabetes Loop in France have CE mark on their algorithm, and they communicate, well it was with Cellnovo, but it's just gone into receivership. They work with our Dana RS pump as well. So we have another system that will be available commercially soon.
Повечето работят с DNR.